Hello and welcome to Aharon. This is the continuation of the second chapter of NCERT 11, which is Units and Measurement. And in this session, we are going to discuss about significant figures and rounding off. So, what are we going to learn here? Let's quickly see them one by one. So, firstly, we are going to study about significant figures. So what is significant figures and the rules for writing significant figures, and all these things we are going to see. Next, we will see that in case of addition, subtraction, multiplication or division, how the significant figures plays an important role, and in the answer how we come to the answer of these mathematical functions using significant figures. The next thing we are going to do is rounding off. So all these things we are going to learn in this session together. So without any further delay, let's begin. Now, as you can see here, the definition for significant figures is that these are used to express the order of accuracy of a measurement. Now, what do we mean by this thing called order of accuracy? Say you have got two values of the same measurement. Number A says that the value of the measurement, say, is 5.4 centimeter, and point B says the value of the same measurement is 5.46 centimeter. Now, out of A and B, we can clearly see that in case of B, it is more accurate. Why it is more accurate? Because there are two digits after the decimal point. So standard way of saying this is that in this A there are only two significant figures, and in B there are three significant figures. So since here there are only two significant figures, so it is less accurate than the B point, which has three significant figures. That's how we can say that B is more accurate as compared to A. So that's what significant figure is, and that's the significance of significant figures, that how it is useful for our mathematical interpretation. I hope it is clear to you. Now then, there are sets of rules by which we can figure out significant figures in a given digit. So what's the first rule says? The first rule says that all non-zero digits or zeros between non-zero digits are significant. As you can see in this example here in number 1, there are non-zero digits, these are non-zero digits, then again these two zeros are between two non-zero digits, that means 8 and 6. So that's why we can say that this example in rule number 1 has how many significant figures? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are total 9 significant figures here. So that's the first rule. I am repeating the first rule, which says that all non-zero digits as well as zeros between two non-zero digits shall always be a significant figure. Now what does the rule number 2 says? It says that zeros in the left of non-zero digits are not significant. So as you can see in this example, so 7, 6, 8, they are non-zero digits, and these zeros are placed in the left of non-zero digits. So these three will not be considered as significant. So in this example, there are only 1, 2 and 3. There are only 3 significant figures or significant digits. Now what does the third rule say? The third rule says that zeros in the right of non-zero digits are significant in nature. So in this example, this 0 is in the left of non-zero digits, so it will not be a significant figures, but these zeros are in the right of non-zero digits, that's why they will be considered as significant. So in this example, how many significant figures are there? 1, 2, 3, 4, 5, 6. So there are total 6 significant figures are there. Now let's quickly recall these 3 rules. So what the first rule says? The first rule says that all non-zero digits as well as zeros between two non-zero digits are termed as significant figures, or they are counted as significant figures. What does the rule number 2 say? The rule number 2 says zeros placed in the left of non-zero digits are not considered as significant figures. So these 3 zeros which are placed in the left of non-zero digits shall not be considered as significant figures. What the third rule says? The third rule says that zeros placed in the right of non-zero digits shall always be considered as significant. So these 3 zeros which are placed in the right of non-zero digits shall always be considered as significant figures. So that's how this quantity right here in number 3 has 6 significant figures. On the other hand, this quantity in number 2 has only 3 significant figures depending on the position of zeros. Now what does the fourth rule say? The fourth rule says that power of 10 are not counted as significant figures. What does it mean? You see, let's take the example of a number which is written as 3.65 into 10 to the power 4, say, meter. Now in this case, as you can see, 3.65, all of these are what? All of these are non-zero digits, so they will be termed as significant figures. There are number 3, but see, 3.65 is followed by 4 zeros which are in form of powers of 10. So the fourth rule says that powers of 10 are not counted as significant figures, so this whole thing shall not be counted as significant figure. So in this case, how many significant figures we are going to get? We are going to get only 3 significant figures because the powers of 10 are not counted. Let's take another example, say 6.508 multiplied by 10 to the power 8. In this case also, see here there are 4 significant figures and there are powers of 10. Now these powers of 10 are not counted as significant figures. So only 4 will be the significant figures placed in this or counted in this digit given to us. So that's what significant figures are, and these are the 4 sets of rules by which you can figure out significant digits in a given form. Now let's move ahead. So here the topic is propagation of significant figures. So how significant figures propagate? Now in case of addition and subtraction, multiplication and division, say there are, let's take the example of addition and subtraction first. So let's take a simple example, say 5.48 plus 5.4629. Okay, so these two are the digits given to us and we have to perform addition between them. So if I do the addition, it will be 924,910. So 10.9429 is the answer of these two digits adding together. But see, What is the least number of significant figures here? 3, right? Or to be precise, the significant figures after point in this case are 2. So the in answer also we shall have 2 significant figures after the decimal point. That's why the answer shall be 10.94. I hope it is clear. Let's understand it with another example. Say I have 6.028 minus 4.01. Now in this case also the answer shall be what? Okay, but see here the least number of significant figures after decimal point is 2. It is 4.01. So in answer also we will have 2 significant figures after the decimal point. So as a result it will be 2.02. Why? I have rounded it off because it is present 8, okay, after 1, so I can write 2.02. And that's how the propagation of significant figures occur. That means in addition, subtraction, also in multiplication and division, the least number of significant figures after the decimal point shall be also counted in the answer. Okay, now let's move ahead. So the next topic is rounding off. Now rounding off is done to a digit in order to get desired number of significant figures. Say we have a significant figures 6.05829. Okay, now our question says that shrink this number into 3 significant figures. That means we have to convert this number into a number in which there shall only be 3 numbers of significant figures. So we can do it by using 6.05. Now in this there are only 3 significant figures present, but there are sets of rules which we should apply in performing this rounding off. Now what are the rules here? We are going to discuss now. Now see, so 6.05, here this 5 is called what? Cutoff digit. And why it is called cutoff digit? Because we have to get 3 significant figures, and 3 significant figure is only possible if we have up to 6.05, up to this. So 5 is called cutoff digit, because while understanding the rules, this cutoff digit shall come again and again, and we have to know clearly what does it mean. Now the first rule says, what does it say? It says that if the number which is lying to the right of cutoff digit is less than 5, then the cutoff digit is remained same. That means suppose we are having a number, say 5.0289.2. Okay, this is an example, and say 9 is the cutoff digit. So how we should write the answer? 5.0289. There shall be no changes. Why? Because the number which is present to the right of cutoff digit is less than 5. See, the number is 2, and 2 is clearly less than 5. So if the digit which remains in the right of cutoff digit is less than 5, then the cutoff digit remain same. That's why 9 remains same. What does the second rule says? The second rule says, say if we want to shrink this number into, say, let's consider the cutoff digit now is 8. That means 5.02892, it can be written as 5.029. Why? Because the second rule says that if the number placed next to or placed right to the cutoff digit is greater than 5, then we can add +1 to the cutoff digit. See, in this case the number placed in the right of cutoff digit is 9. So 9 is clearly greater than 5. So if this number is greater than 5, then we can add plus 1 to the cutoff digit, and after adding plus 1 we can write 5.029. So those are the two rules. Okay, if the number placed to the right of cutoff digit is less than 5, cutoff digit remain same, and if the number placed to the right of cutoff digit is greater than 5, then we can add plus 1 to the cutoff digit. So that's how it becomes 5.029. But there can be another scenario, and there comes the rule number 3, where say we consider a number 02859, okay, and 5.0285 say 4. So, and our here in both the cases the cutoff digits are 8. Okay, that means we have to shrink this number into 4 significant figures, which means up to this. Now the number next to, or the number right to the cutoff digit is 5, which is not less than 5 or not greater than 5, but exactly 5. So in this scenario, what should we do? Then we have to look at the number which is placed right to the 5. If it is odd, now see in this case it is odd, which is 9. Okay, then we can add plus 1 to the cutoff digit, and the rounded off answer shall be 0 to 9. Why it is 9? Because see the number after 5 is is odd. So if it is odd, then you can add plus 1 to the cutoff digit, and if the number next to 5 is even, as in this case, then it shall remain same. So this is the third rule. So let's recall the rules once again. First rule says if the number placed right to the cutoff digit is less than 5, as in this case it is 2, which is less than 5, then the cutoff digit remains same. If the number placed next to the or right to the cutoff digit is greater than 5, then you can add plus 1 to the cutoff digit. But what shall happen if the number placed right to the cutoff digit is 5? Then we look at the next number. If the next number is odd, as in this case odd, why? Because 9 is an odd number, then we can add plus 1 to the cutoff digit, and the answer shall be 5.029, as in this case. And if the number placed next to 5 is even, then the cutoff digit remain same, as in this case. So therefore it is remaining 5.028. So that's what rounding off is, and these are the sets of rules which you can apply doing rounding off. With this, we have come to the end of this session. Now thank you for tuning in. I hope you liked it and learned a bit. Thanks for watching again. This is Shomik Shah signing off.